Hello, everyone, and welcome back to our series on energy modeling applications with Honeybee. And in the previous video, we worked on building this construction set that represents a kind of passive house in climate zone 3 in a warm climate with these nice adobe brick walls on the interior and these nice triple pane constructions. And in this video, we're going to actually apply this construction set to our single family home energy model to understand the impact that the change of these constructions will have on the thermal comfort within the space. So I provided you both the link to this sample file of what we've worked on in the description, as well as the link to the file that we are working towards here, this model of our single family home. And just to refresh your memory, this model is a 7-zone room house here, and you can see that we've been looking at the surface temperatures of the inside faces, and it's really these surface temperatures that we want to change with our new construction set. So the first thing I'm going to do, I'm actually going to try and organize our energy model here of our single family home a little bit better so I can then more easily apply these construction sets to it. So all right, I'm just going to do a little housekeeping at first. I'm going to take all of these components that are actually responsible for running our comfort analysis down here, and I'm just going to group them together. I'm going to select these all and group them together. And let's see. And I think some of these components I don't need anymore, like the ones that are reading the room energy result here. I'm just going to delete that so that I can more easily make some space for these other results that I'm importing here. And visualizing on these color rooms and color faces, maybe I'll group these as well. Let's see, I can group my simulation parameters, just trying to keep everything organized in this definition here. And again, if you guys are starting from the actual sample file in the link, this is all going to be organized for you. Maybe one last thing, I don't think we really need to preview the model here that we created. I'm just going to delete these components for now. All right, and maybe I can create a little bit more space here. So just as a refresher, you'll remember that we've plotted the percentage of time that is comfortable on these rooms of our model here. And if I were to turn the preview off on these color faces here, I can then turn the preview back on, let's say on these color rooms, which we know is just coloring the rooms with their operative temperature. And these numbers are actually the percentages of time that are neutral, that are neither hot nor cold. And we can see that a lot of these numbers are not really where we'd like them to be. They really ideally should be closer to something like 90% or at least the high 80s. And while we're getting close to that within rooms like the central room in the middle of the house here, we can clearly see that especially these perimeter rooms that have a higher amount of glass, these ones are not very comfortable at all. If I told you that you were going to be uncomfortable for 40% of the time in this space, that would be pretty bad. But maybe actually we can do one thing better, because right now we're looking at the condition of the people on this hourly plot. And we can actually notice that many of the hours that are thermally uncomfortable are ones where we're going to be asleep. A lot of these hours in the early morning are essentially the most uncomfortable ones. So maybe we can actually, before we even go and apply our construction set, we can go and narrow down the hours to just those that are occupied so that we can get a better sense or a better representation of the discomfort in the space. So I'm going to do this very quickly right now. A lot of this should be a review from the fundamentals of Ladybug and working with data in Grasshopper and Ladybug. But I'm very simply just going to put together an analysis period. So if I go over to my Ladybug tab here, and I will grab this component called LB analysis period, and this will allow me to select out just a time range of the occupied hours. So I can say as a start hour, let's say that we start occupying this residence at around 8 a.m., or at least we're waking up around then, we can say. And then let's say we'll go to bed sometime around 10 p.m. So I'm going to bring up a panel that has 22 inside of it here by double clicking the canvas, typing double quote, and then 22. And this will give me an analysis period object that I can then apply to the inputs of our PMV comfort model so that I can select out just the time range in between these 2 hours. So let me do that right now. There's this component called LB analysis period, or I should clarify, LB apply analysis period. If I drag and drop this onto the canvas, you'll see that this can take data like our air temperatures here, for example, and it can take this analysis period like what I have here, and it will apply that analysis period to that data. And you can actually see in the outputs here that all of these data collections are now going from 8 a.m. to 10 p.m. And I guess I'm just going to copy and paste this a few times. I'm going to copy and paste it a couple of times so that I can also connect up the radiant temperature as well as the relative humidity. And I know things are getting a little messy here, so I'll try and move them around a bit. But I think the next thing I want to do, I'm going to set this toggle to false on the PMV comfort map so that I can then plug in the relative humidity, the radiant temperature, and the air temperature to the respective inputs of the comfort model. And I'm going to try and organize this a little bit better here so we can see this all together. In fact, why don't I even add this analysis period and these components to this group here. So I'm going to just select them and right click the group and say add to group so that they're all now inside of the same comfort evaluating group. And then lastly, I think I just need to make sure that I apply my analysis period to the clothing values that are going into this comfort model. And you'll see there's actually already an input for this. I don't really need to post-process them with this LB apply analysis period component. So I'm simply going to plug in that same period to this component here. And then I think everything should be aligned so that I can just go and take this little toggle and run and set it to true. And it'll take a few seconds to run that PNV comfort model, but after it's done, we'll get a plot of just those hours that we were concerned with, right? So this is just between 8 a.m. and 10 p.m. here that we're seeing the comfort conditions. And let's see if the actual percentages have changed at all. Certainly we can see that there are hours that are too hot there. And okay, all right, at least we can see the central space is probably good to go as it is. If we're getting 94% of the time inside the comfort range, I think that's pretty good. Maybe some of these bedrooms are also pretty good, but clearly these rooms on the south here, they could definitely benefit from some better constructions. I mean, still, if I told you that more than 30% of your occupied hours are going to be uncomfortable in this room, that's just not going to cut it. That's not a really good design space. So all right, so now that we've set our model up like this, I'm going to make Grasshopper large. And let's actually bring our construction set into our energy modeling Grasshopper script here so we can then apply it to our model. So I'm going to go back over to our creating construction sets Grasshopper definition. And so there are a few ways I can actually bring this construction set into the other Grasshopper definition. Certainly I can just try and select all of these components that are creating this construction set. I can copy and paste them into the other Grasshopper definitions. But it's kind of nice to organize things into their own Grasshopper files. So I'm going to show you at least one way that you can internalize the entire specification of this construction set inside of a component so you don't need to copy and paste everything that you have in here, everything that's creating this construction set in your other Grasshopper definition. This will essentially allow you to make things a little bit cleaner. So you'll see that out of this component, this HB construction set component, we're actually getting an object. This is an object representing the construction set that we've created. But this object can actually be represented as a bunch of text. And the easy way that we can convert this object into a bunch of text is using some of these components under the serialize tab here. So specifically, there's this component called HB object to string. And if I drag and drop this component on the canvas, you'll see it can tell us that it will serialize any honeybee object, which can either be a construction or a construction set or schedules and loads or programs, which we'll get to eventually. And it can serialize them into a bunch of text that fully describes everything that's going into that construction set. So if I go and connect up my construction set object to this HB object to string component, and I'm going to copy and paste this panel so I can take a look at the output. What you guys will see, this is going to be a little bit of stuff in code here, but this is essentially a whole representation of this construction set. You'll see that it actually includes the individual materials that are going into this construction set. It includes the definitions of the constructions themselves, and it includes the logic of how these constructions are applied to the various different surfaces. Now, I'm not going to get into the whole details of what this actual language specification is or what this schema is, if you will, but it's essentially a JSON representation of this object. And very importantly, this is completely text. There's nothing else that is needed to describe this construction set other than this text here. So the reason why this is useful is that I can now take a native Grasshopper text component, and if I just search for this by double-clicking the canvas and typing text, I can then go and connect up this text, this string representation of the construction set here. And this will allow me, if I right click on this text object with everything connected and say internalize data, that is going to disconnect this text from the HB object to string. But because that text is internalized now, I now still have this full set of code here, this full schema representation of this construction set here. And the really nice thing about this is that instead of having to copy all of these objects, all of these constructions and material components into my other Grasshopper definition, this is actually the only thing that I need to copy into the other Grasshopper definition. So why don't I do that right now? I'm actually going to select these two and hit Control X to cut them to my clipboard. And if I go over to my energy model Grasshopper definition, I can paste these two components into there, this text and this panel that I'm using to display that text. And you'll see that under the Serialize tab, if I go back up to the Serialize tab, you'll find that there's another component that's meant to take this string representation of any honeybee object and rebuild the entire object of that so that I can then apply that to any of the geometries in my model here. So I'm going to drag and drop this HB string to object component onto the canvas here. And you'll see if I were to connect up this string representation of the construction set to this component, then out of it, I'm going to get the exact same construction set object that I serialized in my other Grasshopper definition. So again, this is all that I need now in order to bring this construction set from another Grasshopper definition into this one. And there are many ways of using this kind of string representation of honeybee objects. We'll get into some of them later, but this is one that I'd really recommend if you don't want to make your Grasshopper definitions really messy with a lot of different components to create various construction sets or other objects in your energy model. So all right, so now that I have this, I'm basically ready. I can take this actual HB object and plug it right into the construction set here. But before I go and do that, I want to make a few changes to my model. So I'm actually going to go to the component that's running the simulation. And I'm going to double click this little toggle to set it to false. And this will allow me to make edits to this model that's going into the simulation component without rerunning the simulation every time that an edit is made. So, okay, so now that I've done this, I'm very simply just going to replace my Climate Zone 3 wood frame construction set. I'm going to replace this with my new construction set that I've built and reserialized in this Grasshopper definition. And I've come to realize I actually want to make one more tweak to this model before I go and simulate it. That is related to the constructions, and that's that this mid-rise apartment program that I'm applying to my rooms here, the air leakage that is associated with this program is probably not really well aligned with the actual high performance constructions that I know I have in this construction set. So what I'd like to do is actually tweak the infiltration levels of this mid-rise apartment program so that it's a bit more representative of the tight envelope that I'm trying to represent with this construction set here. So I'm very quickly just going to take this mid-rise apartment program, and I'm going to grab this component that's just simply called HB apply load values. And I'm going to drop this onto the canvas here. And you'll see that I can simply plug the program into this component, and this will allow me to tweak the infiltration that's assigned here. I can certainly check what the infiltration value is, but I actually know for a matter of fact that it's around 0.0006. And I'd like to convert this to something a little bit more tighter, a little bit of a tighter envelope. So something around 0.0003. I think that's probably a good level of infiltration. And again, the units of this are in cubic meters per second, and that's per square meter of exposed envelope area. So the more envelope that a room has, the more infiltration it's going to have, the more air leakage you're going to have through it. So I'm just going to do this very quickly, and we'll cover things like infiltration a little bit more in the coming videos. But right now, I very simply just want to make a panel that has 0.0003 inside of it. And I'm going to connect that to the infiltration per exterior. And this is going to give me a new program object that I can then go and plug into my rooms here that are a part of my model here. So, all right, so with these two together, I have my fancy passive construction set, which is replacing this Climate Zone 3 wood frame default construction set. And I've altered the program a little bit so that the infiltration or air leakage is a little bit less. It's a little bit of a tighter building. So with these two changes, I'm actually going to rerun the simulation now. So I'm going to go back over to the simulation component. I'm going to double click this toggle to true, and we're actually going to execute the simulation. Now, this will take a few seconds, but I want you guys to just remember that that center room was still pretty comfortable. It was in the 90s before, but the percentage of time that was comfortable in those perimeter spaces, that was as low as, I believe it was 58 or 59 or so percent of the time. So we're going to see, if, especially in those perimeter spaces, if this new envelope has improved the comfort. Okay, so it took a few seconds there after the simulation finished for it to actually recompute the comfort. And we can see that all the other components that come after this simulation component have rerun now. And I'm getting updated percentages, but I don't want you to see those yet. What I want you to do is that we'll go back over to the Rhino scene. Maybe I'll just put Grasshopper off to the side here. Okay, behave, Grasshopper. Oh, and look at this. Look at these new percentages now. So we remember, right, this room was all the way down in the 50s or 60s before, right? Now it's all the way up at 80%, which is still not perfect for sure, but this is a big, significant improvement. There's definitely a quality and value that has been added to this building by using these better performing constructions, both the better performing windows, and I'm sure that those thermally massive walls, tighter envelope with less leaky air also helped quite a lot too. And so we can go over, let's say, to the top view where I have the actual display of these conditions, and we can see, lo and behold, that almost all the time, especially in some of these rooms, we have pretty much all the time is in the comfort range. Maybe we have a few hours at night where it starts to get a little cool, where honestly we may be going to bed anyway. I could probably live with that level of discomfort, but this is certainly an improvement. And we do still have a few hours of overheating happening. This is probably why that room that I have over here is not at a full 90% or close to 100%. We still have a few significantly hot hours, and maybe this room can get a little bit better with some shade per se, but this has already proven the value. Clearly there's value added by having these constructions like this. And honestly, these constructions like adobe walls, these are very difficult things to justify purely using energy savings or reductions in the size and cost of HVAC systems. So being able to make arguments like this in terms of thermal comfort is really valuable. It's really powerful in terms of arguing for these types of strategies. So, all right, so we've come full circle with understanding two important criteria. So we understood how to make constructions and construction sets so we can evaluate their impact on buildings. And you guys have learned a new way of evaluating that impact, which is in terms of thermal comfort. In the next video, we're still going to look at the impact of these constructions, but I want you guys to understand at a better level of detail some of these other ways of arguing for the value of a certain strategy. And specifically, we're going to come back to our world of metrics here, and I want to go back to some of these other ways of arguing for strategies in terms of environmental impact and monetary costs. We're going to delve a little bit more into those before going to build a larger model and getting some experience with something that's probably closer to what you'd be designing as someone in an architecture engineering office. So with that, thank you guys for sticking it through this video. We've come to a completion of showing the value of a strategy, and I look forward to delving into some of these other ways of showing the value in the next video.